Hello students. In the previous video, we learned how to calculate mean for discrete data. That is, ungrouped data in tabular form using direct method. Today, let us learn how to use same method to find mean of group data. But wait, first look at this table that we made in our previous video. It shows we have shortened the table by forming groups. Yes, we have formed classes of width 15 each from the given observations, and we have shortened the table. Here this column is frequencies Fi, which is nothing but the number of students scoring the particular marks. So now let us learn how to find mean for this table. We will have to find its midpoint, also called as class mark. This is because in class there will be more than one observation. So which frequency belongs to which observation cannot be determined. For example, in a class of 10 to 25, there are marks ranging from 10 to 25. And so we cannot say that its frequency 2 is for which mark, either 10 or 11 or 12 and so on. So we find the midpoint of each class, which will be the representative observation for all individual observations falling in that class. I know you must have learned how to calculate class mark or midpoint of a class. If not, so pause the video, take a second and find out the midpoint or class mark for all the classes. If you cannot recall it, let's quickly see it. To calculate midpoint, take upper limit and the lower limit of the class, add them and divide it by 2. Calculating all the midpoints, we get values as shown. Accordingly, for the first class, midpoint or class mark is 10 plus 25 upon 2, which is equal to 17.5. Similarly, we can find the class marks of remaining class intervals and note them in the table as shown. Here, these class marks serve as our xi's, that is, our individual observations. We also have the frequency Fi corresponding to that class mark xi. So you already know, students, formula to calculate mean using direct method. Yes, exactly. It is sigma Fi xi upon sigma Fi. So students, use this formula and quickly find out mean of this group data by direct method. So we get 1680 upon 30, which is equal to 62. Thus, mean of the given data is 62, which means most of the students have scored marks somewhere between 50 to 60, but some students must have scored less than 50 or more than 60 as well. Now students, observe carefully. We have used same data to calculate mean both the times. Then why is the mean calculated from discrete frequency distribution table and grouped frequency distribution table obtained different? Can you answer this question? Pause the video, take a second and think for the answer. Could you answer it? Let us see whether you have answered it correct or not. Students, even though we used same data both the times, but still we obtained mean different is because of the midpoint assumption in second method. Actually, while calculating mean from discrete data, we didn't assume observations and their frequencies. They were actual and exact values. But while calculating mean from group data, we assumed one representative value for many observations in our class. For example, here we assumed 17.5 marks as a representative observation or representative value for all marks between 10 and 25. Thus, when we calculate FIXI, there will be some assumptions, which will create little variation in calculated value of mean in the second method. And thus, we get different mean even though data and method used both the times were same. But students, this difference is very small and can be neglected against a huge data that we are analyzing. Now students, mean for group data can be calculated by three methods: direct method, assumed mean method, and step deviation method. We have already seen the first method in case of grouped data. In the next video, we will see another method, assumed mean method, to calculate mean for the group data.